Welcome to Connect with BMC Helix webinar series. Today's webinar topic to AI or not to AI, the service management conundrum. This is being presented today by Harshad, Borgaonkar and Ajoy, Kumar, our R&D solutions architect. Please note all participants are muted due to the number of attendees. We will, however, during the different points of the webinar have an opportunity for questions which will be done through the Q&A section. So if you do have any questions, please use that section of Zoom. Thank you.
Hey, thank you, Sam. So my name is Harshad, and I am the product manager for AI service management. And let me welcome you all to this webinar on to AI or not to AI, the service management conundrum. And today I'll be joined by my colleague Ajoy Kumar, who is our R&D solutions architect.
Hi, I'm Ajoy Kumar, and I'm the AI architect for some of the exciting features you're going to see today.
Yep, thank you, Ajoy. And again, along with Ajoy, we'll cover this agenda, which is to look at a brief introduction on our AI capabilities in ITSM. We will then cover the AI technology strategy and the general direction that we have set to enable our use cases. We will then explore the more exciting part that happens to be the application of AI in ITSM, and in which we will initially talk about the two new ticket clustering use cases around proactive problem management and real-time incident correlation. And then we will talk about how AI service management enables self-service through the newly launched capability around auto reply to emails. And then towards the end, we will present the case for change along with some more important information on SaaS licensing. And finally, we will do a deep dive into the AI and ML technology that enables our use cases. But before I begin, let me start by asking you, when was the last time that you used AI in your everyday life? You can answer this question through the Q&A window. And I guess most of us have got this. So we use AI almost daily. When we use our faces to unlock our smartphone or even our fingerprints to unlock this smartphone. And then when OTT platforms show up recommendations on what to watch next based on our history and feedback that leverages AI. So it's really a part of our lives today, a must for delivering superior customer experience. So with that, I would like to start with that, by pulling together some of the blocks that are really needed today to deliver a holistic customer experience through the use of transformative digital technologies, be it AI or mobile or cloud. Now, a good place to start digital transformation, and as most would agree, is by first focusing on employee experience and employee engagement. And then again, digital employee experience could be more of a buzzword today, but the way we perceive it is as a combination of how employees experience technology within the organization, and also how IT departments work with individual employees to address their issues, their service requests, ensure reliability of apps, and provide means for communication and collaboration. Again, talent is increasingly hard to get, so talent retention, employee engagement, employee empowerment are really vital. And I'll not preach to the choir here. But then the touch points with digital and the extensive use of digital can be a true test of how engaged and empowered our employees are to do their jobs and from wherever they are located. Then there is the ever evolving requirement to manage IT risks that arise because of this mesh between modern technologies and the legacy applications or legacy systems. So, companies aren't going to retire their COBOL systems, anytime sooner and move to cloud-based apps, which means that both will coexist at least for the near foreseeable future. It also means more complexity in managing service support, more complex apps, and explosion of data. So again, intelligent ways are needed to ensure that business strategies are insulated from this underlying web of complexity. And then lastly, there is DevOps. It has a huge role to play when there is a need for faster and more frequent code changes as product owners and product managers in companies continue to deliver innovations, refine the end customer experience. And their focus is primarily on customer experience and on delivering improvements. And we are experiencing this fundamental change of mindset that is focused on the customer. So that, along with the operational and IT improvements, is really going to be the key to unlock business value. And again, business value cannot be delivered by working in silos or relying on traditional paradigms. And this is where service ops comes in. And what it is that it is really a convergence. So I'm going to throw in this definition on the screen here. And what it really says is that with service ops, we are providing a set of tools to our customers so that they can fully leverage their investments around service management and operations management. And this is really critical today to deliver a truly modern service experience. So AI and collaboration are really at the heart of it, as is the unified view between service and operations that cuts across multiple lines of business. So, an unified view on a single environment, a single database to deliver end-to-end outcomes. And this is really, the realms of service ops. And this is also what the likes of Gartner are pointing out at. So it goes beyond the traditional, the core ITIL framework, where newer practices like DevOps, SRE are increasingly adopted. Therefore, a key aspect of service ops is to embrace newer practices, new technologies to enable collaboration and go beyond the traditional realms of ITSM, which therefore means investing in DevOps, SRE, investing in AI, investing in new technologies. So with that, I'll come to our AI capabilities in ITSM. So we really have quite a bunch of them that are available in ITSM today around classification, such as auto ticket categorization or change risk classification. Then we have tone analysis, chatbot. We have cognitive search, also real-time language translation, as well as some of the other capabilities that we deliver through our alliance with partners that are around change risk prediction and reporting. And we had introduced these two ticket clustering use cases in the 21.02 release last year. And again, both these use cases, proactive problem management and real-time incident correlation, are based on clustering, which then internally works on AI capabilities around NLP, K-means, BERT algorithms, very sophisticated, powerful ones. Again, both these use cases are unique, and in that they really solve two major challenges around problem management and incident management. And then we have introduced this new use case in 22.1, which is around auto reply to emails with knowledge articles. And this can be a really effective tool for service desks that rely on email-based incident logging. So again, integration with AI ops is at the cornerstone of everything that we do. And this is one of our unique differentiators. And with this, it brings us to an important question, which we are asked on many occasions by many customers in terms of our technology direction. And the concern is chiefly around certain dependencies on IBM Watson or on-prem support, because on-prem support is a challenge with IBM Watson. So I'll cover the overall change in technology direction that we had in terms of AI last year. And the first is, while we will continue to use the best of the breed technology approach. So, we will continue to use IBM Watson for chatbot. For language translation, it could be either, Google Cloud or Azure. And for speech to text, it could be Azure. So this is because it makes sense in some areas where the capability required is very generic and it is really difficult to build it in-house. So in a classic build versus buy scenario, it is better to leverage what is already available and the one that is getting continuously refined. But then our main goal is to transition to a converged server that is based on AI foundation wherever possible. So going forward, all the apps, will run on converged server. So again, data lies in converged server, and they have APIs to connect to either the ADE, AI Foundation, or the public cloud providers. And so with that, what we really have today is a really modern architecture with lots of open source components. And again, Ajoy will cover this in details during his presentation later. But let me just cover this on a very high level. So our objective here is to use best-in-class industry standard components and to avoid our customers the overhead of doing this research. So we make sure that our algorithms are properly trained, they are properly integrated. The abstraction layer that we provide via AI Foundation, allows us to easily replace algorithms and models, whenever there are better technologies that are available. And this is something which our competition won't be able to do, given that they do their own technology. So that is a key unique differentiation between BMC and our competition. So with that, it brings us to the first AI use case for today, which is around proactive problem management. And then let me talk about this use case. But before that, I just want to cover that, during our initial research and our early customer conversations, the one thing that really came up as a challenge or a pain point for our customers, was the need for them to proactively manage problem investigations. And before we take a deep dive into this use case, I'll talk more about the specific problem that we are trying to solve. And this will require us to dig a bit deeper into a persona and their specific pain points. So we will look into the typical day in the life of a problem coordinator. Now, we all know that one of the pain points for a problem coordinator is to identify the most valuable ticket clusters so that they can be looked at from a problem investigation perspective. And again, problem investigations, as we know, are a very costly process. And that is why, problem coordinators, prioritize them very diligently, so as to look only at the most impactful set of recurring incidents. Because again, there are too many tickets. You cannot pick all the tickets to perform problem investigations. It's really impossible. So they select these tickets manually. And again, when done manually, it takes several days because part of the issue is to analyze the key information on the ticket, which comes as free text. And the other part is where these tickets need to be grouped and problem investigations need to be created. And again, both are tedious and time consuming activities, which is one reason why problems go unmitigated today. So what we have done is we have applied a combination of NLP and AI clustering to solve this problem really. And we have used the traditional k-means clustering, which is an unsupervised learning algorithm, as again, we will explore later during Ajoy's presentation. But what it really does, it helps classify historical tickets into these high value clusters and makes it easy for problem coordinators to target the most recurring ones. So the way this works is that we build these ticket clusters by taking 1 month or 2 months or 3 months of data, or maybe even a year of ticket data, and then run the algorithms through them in batch jobs, which is typically an offline process, and it can be a monthly process as well. And we've seen that a monthly process is a sweet spot for most of our customers, but ticket volumes here would really decide if you really need to run this process monthly or weekly or once in 3 months. The algorithms then identify similarities in the ticket data and clusters them into groups, which can be handed over to the problem coordinators. And this is more around the AI engine part. But then what we also have, as you could see on the screen, is very effective visualization through dashboards and also the ability to take actions of this, which is what really makes this work, right? So when users see this intuitive dashboard, which displays, these problem clusters, these incident clusters, it really makes it easy for them to target the most recurring ones. Now, the benefit of this use case is in terms of efficiency, simplification, and increasing productivity. So on the one hand, we are now able to reduce the efforts for incident analysis and problem creation by running the clustering jobs in the background that creates the incident clusters. and then again seamlessly launches into problems of it. But then on the other hand, this aids in an improved identification of your most valuable ticket clusters, which ultimately supports reduction of incidents, to your service desk. And then lastly, there is better alignment around focus areas through data-driven decisions and good visualizations. I'll just take a pause here and see if there are any questions. Sam, do we have any
We did have
questions?
a question, but Peter's answered that for you. And actually, one's just popped up as we speak. Where can I find information on more webinars for ITSM Insights?
Yeah, so there is a webinar that we had delivered last year, which also contains the demo. And towards the end of this webinar, I'll share the link with that as well.
Thank you. And
And then
I'll
again,
also share it
yeah,
out. I
and
was going to say, yeah.
yeah, and then we have our AI service management community group. So I think we can keep the conversation going through that group as well.
Okay, that's the only question. And what I'll do is if you share those links with me, I'll put them out in the survey that will go out to the customers after this webinar.
Sure,
Thanks,
perfect.
Harshad. That's it.
Yep.
Back to you.
Yep. Um, and the second use case that we indicated earlier is the real-time incident correlation one. And the major difference between this and the earlier use case is that, while proactive problem management deals with historical tickets, then incident correlation works with real-time incidents. So think about real-time incident correlation as a counterpart, a cousin of proactive problem management, which is also based on ticket clustering, but which deals with more real-time incidents as they come into the service desk. So what you're really doing here is that you're clustering the incidents on the fly, and then you're able to understand which of these incidents are about the same underlying issue or situation. And this becomes really critical, as a flood of incidents could indicate an emerging impactful situation like a major incident. So the persona here that we're talking about is that of a major incident manager. And if you look at how they detect emerging situations today, then this is largely through the word of mouth, where agents could look at a ticket console here or a dashboard there, maybe some reports, and make some suggestions. Overall, again, this is a very manual process. And what customers, indicated is that they needed an analytical process, that helps them to identify these clusters of incoming incidents. It also would help them to understand what is currently going on in the service desk. So a dashboard that shows emerging topics in real time would really facilitate a quick and coordinated response. And what is needed is a way to formally relate these incidents and reduce any duplicate work so that incident management activities, such as notifications, etc., could be streamlined. And then lastly, you would need system guidance such as probable cause analysis to restore the resolution, to restore the service as fast as possible. So again, these are some of the requirements of a major incident manager to help them perform their jobs better. Finally, customers did indicate that they needed a way to link an incident to a probable cause analysis in AI ops that would enable faster resolution of issues where users can explore the probable causes, look at the nodes in the topology, and identify the likely cause. And then coming to our solution, what we have done is that we have leveraged AI-based algorithms such as BERT to accurately identify incidents in real time that are related to the same underlying situation. So what you see on the screen here is that we have an incident command center of sorts to understand these emerging incident topics in real time. And again, these incidents are clustered, and we can manage duplicates so that incident response teams, they understand the patterns, the duplicates that are associated with them, and then they can focus on solving the original incident. So that saves a lot of these duplicate efforts around managing, these real-time, major incidents. Um, and again, we have introduced a key feature around real-time incident correlation, and this is in the 22.1 release. And again, with this, we are bringing incident correlation closer to major incident detection by predicting major incidents that are based on several parameters such as the upward trend in a cluster, the number of incidents in a cluster, and the number of new incidents in the trend window, all of which are configurable parameters. So when you look at so when you are looking at the IC billboard, you also know what actions are needed, like creating a major incident candidate and so forth. And this is really based on the data analysis that is done by the models and the recommendations that is put forward by the machine learning algorithms. And this trend is one useful way to slice and dice the real-time data on incidents. So we are now also supporting the sorting by trend, in addition to what users have today in the sort by drop down. So this will allow users to understand what has transpired in the trend window, which could be the last 2 hours or the last 4 hours, as opposed to only having the bigger time window, which is a couple of days or a week. And the trend window is again a configurable item. And then lastly, we now have support to search by the cluster name so that users can search by the name of the cluster instead of having to search for it on the whole dashboard page. Scroll down and then look for the cluster is not a very effective way of searching for a cluster. And then again, talking about the benefits, the current efforts in identifying duplicates are avoided because the AI clustering jobs can correlate incidents together. The UI provides an easy way to mark duplicates. And again, getting real-time information enables faster reaction time to emerging situations, and this helps in reducing downtimes of applications or services. And this becomes very important when a service is very critical. Lastly, again, this configurability to detect major incidents is where customers can refine the system by their scenarios. Also given that there could be multiple stakeholders working on a major incident, this feature becomes very useful. It leads to an improved coordination between various stakeholders that are really involved in major incident type situations. Um, and again, AI-based automation is a key focus for us to improve the IT employee experience and driving digital transformation, as we touched upon earlier. And this focus on AI is, as one of the enablers for automation that takes away the repetitive, mundane tasks that are typically performed by agents, and then allowing the agents to focus on more value-added activities. So one of the key innovations in 22.100 is around auto reply to emails with knowledge articles from Helix Knowledge Management or come around. And this is especially going to be very useful for service desks that are primarily based on email-based incident logging. So for them, it is really going to be a blessing, a very useful tool. And what this feature really does is it understands the intent of the end user emails through natural language processing, and then performs this email to knowledge articles classification, and then sends the end user the top 3 knowledge articles from Helix Knowledge Management, based on relevancy, based on context of the user query. Again, there could be cases where the model would not find the right knowledge article. It might be because it's a complex query or a relatively newer one. So in those cases, it follows the normal process of incident creation with the applicable incident templates. Now, self-service has been, one of our goals in the past as well. But with this, we are taking it to the next level by allowing our customers to empower their employees to solve issues by their own. And then, of course, as AI models continuously learn and are trained on additional scenarios, is when you actually realize this benefit, which is to reduce the number of incidents in the service desk, cut down on the amount of repetitive work, and this would have a direct impact on IT employee satisfaction and experience. It also empowers end users to solve their own issues with the help of the relevant knowledge articles, which could be faster. And again, that could be done without needing any intervention from service desk. So again, a very useful feature for standard incidents that typically constitute a large part of incidents in a service desk. And if you are really wondering, if you really need to build this case for change, or need to know the reasons to upgrade to AI-based functionalities, then the answer lies in putting in modern support technologies, embracing newer practices, as we discussed earlier, that can solve cases and incidents faster, use resources optimally, enable self-service, and eventually help in making the organization agile. And this can lead to improved time to resolutions, higher employee satisfaction, promoting self-help, and then presenting actionable information to customers when they need it. And again, AI and ML are major drivers to enable this type of a modern service management. And the key goal of AI service management is to augment the human experience and make digital transformation smoother. Lastly, in terms of SaaS licensing, just wanted to point out that AI capabilities are available with the suite user licenses. So also BMC teams can help customers determine the number of suite user licenses required. The one thing to keep in mind here is that the same list price is applicable for different cloud options. So that is something which, again, we are asked on multiple occasions. So just wanted to present it here on this slide. Um, and with that, let me hand it over to Ajoy to do a deep dive into the AI technology. Ajoy, take it over.
Thank you, Harshad. Now we are going to talk about some of the underlying technology that drives the exciting use cases you just heard today. I'll talk about the overview of the models, and then we will deep dive on the three algorithms that we have implemented. Let's look at the high level AI models that we use. For proactive problem management, we use k-means. This is essentially takes a historic set of incidents and groups them into clusters. We will also talk about best practices for doing proactive problem management. There was a question in the chat window on what are some of the practical implementation choices or approaches. We will talk about that. Then the second algorithm we have is incident correlation, which is driven primarily by distilled BERT. As you might know, there is a lot of research going on in NLP technologies, and we use one of the latest models, distilled BERT, which is open source. Google uses variations of these models in running searches. We are using it to detecting the intent similarity between the incidents. We'll again talk more. We'll talk more on how this happens. And then finally, the most recent algorithm we implemented is email auto reply. As you know, 40% of IT support is all through emails. If these algorithms will help you auto reply with knowledge articles. And then some of the key models we use here are Rake and LDA. So let's dive into what is clustering. As you already heard from Harshad, a cluster is a meaningful group of incidents. What you see here on the left side is a cluster of connection issues. You have Skype connection issues, VPN, all of them are talking about connection issues. So these three incidents have been grouped together. On the right side, you see another green cluster about a VPN issue. All these dots represent individual incidents. The primary way we do clustering is looking at the text inside a incident. The text may not match exactly like you see here. Please reset my password, VPN password reset. The text may be slightly different, but we understand that they both mean the same thing. And that's how we group them together. So that's the power of NLP technologies that we use in determining these clusters. Finally, these clustering algorithms, the two algorithms we'll talk about, both are unsupervised. So there is absolutely no training needed. One, you can pretty much get started with a few clicks. So let's step back and see what is a typical machine learning life cycle. In a ML model development, you start off with a model, put some parameters to begin with, you run your model, then you look at the model and see, hey, is this model good? Am I getting the results or the outcome which I expect? If it's good, you can push it to production and everything is good. You're happy. If you don't like the results, we provide a lot of tools and capabilities to tune the parameters. We'll talk about both these aspects on how to tune parameters as well as how do you evaluate the results. And then we will cover some of the best practices. So let's look at tuning. As you know, ML algorithms need tuning, and these are the 5 ways where which you can use to tune each of the algorithms, proactive problem management, as well as incident correlation. Some of these apply to different algorithms. So one of the first things you can do is text, right? I mean, you need to know, should I cluster on description? Should I cluster on detailed description? Sometimes you want to cluster on the resolution nodes. All of these are text fields. And that's what our NLP engine will look at those and start looking at similarities using the powerful language models behind the scenes. So the text field is the first important parameter. As you see, there are a lot of words in the enterprise which are very repeated, and sometimes they can confuse these algorithms. Like you could have company name or certain other words which really don't matter for clustering. These are the kinds of things which you can ignore. So you can definitely have an ability to update your stop words. Group by field, that's the third parameter. It really allows you to build cluster boundaries. We'll talk about that. It's a very important parameter, which will largely dictate how your clusters are formed. The next one, as you know, as I said before, proactive problem management is using k-means. Number of clusters, determining that is always a challenge. If you have the right domain knowledge and in terms of, hey, how many problems do I generate annually, then you can use those as your starting point for determining the clusters. But we do even better than that. So we have optimal k, so you don't have to do a thing. The system will automatically figure out the right number of clusters to form. And then finally, the similarity threshold. This is used in incident correlation, the real-time IC algorithm, where you set a threshold which determines how close you want the tickets to match. You set this to a very high threshold like 0.9, or you can set it to a low threshold. And this will again change the dynamics of a cluster. So what you see here is the tuning part. We provide a number of options to fine-tune your algorithm. And in many cases, you don't have to do this tuning yourself at all. You can have the system pick the right set of parameters. So now let's look at evaluation results, right? Obviously, you can look at the clusters and do a visual evaluation. But for PPM, we even do one step better. We provide you a job quality score. So what you see here on the UI screen, you can see whether a job run which you have done is the quality excellent, good, or not that great. If the quality is not that great, then you can go back and change the parameters. So essentially, that's what we talked about today, that you can tune the parameters and then you run the job, you evaluate. If it's good, you're all set. And like in PPM, you can really schedule the job every week or every month. If it's fine-tuning. So we'll talk about a deep dive on some of the important parameters. What you see here is a group by field parameter, which you can set as a part of defining a proactive problem management job. So what on the left side you see is a group where you have not specified any group by, and you will see really heterogeneous clusters. So this is a password reset cluster, but you have Teams incidents in it, you have VPN incidents. So you may have a mixture of different technologies. But then one of the things we have found talking to customers is customers organize their IT in terms of ownership, or in terms of technical services, in terms of business services. So one of the things that you can do is specify a group by service. So that's what you see on the right side, where you run with the same data, you run with a service as your group by field. And now you will start seeing homogeneous clusters, and you will see these hard boundaries. So whatever is your group by field selection, like in this example, it was a business service, then that forms your hard boundary, and then you will have clusters within it. So you can think of group by as providing you some way to do hierarchical clustering, where the first level is a set of categorical parameters. You can pretty much pick any non-text categorical field, like a service field or a company field or others. And then within itself, within that category, you can start getting clusters. So you can see like, hey, these are all, you can see there are two teams cluster, and these cluster of incidents are very homogeneous. So all these clusters will be for that group by field, like for one service. And this really helps organization in problem management, because now if you have multiple problem managers, one for a technical domain, then they can pick their clusters and focus on Teams issues or VPN issues and so on. So that's one of the power of the capabilities that we provide, that you have a lot of flexibility in terms of trying out all these different options. And once you like some of the parameters with the results you're getting, you schedule that job in PPM. And these are some of the practical implementation guidelines that we have. Next, I will cover the data processing pipeline. This is your typical NLP pipeline that we have implemented, and stop word removal is a capability that we provide. Sam, are there any questions? Let me pause here.
There was, or there is, but one's being answered by Peter, so we're okay to carry on.
Okay, thank you.
Thank you.
Okay, so I'm going to deep dive on K-means and on proactive problem management, and then we will look at the next algorithm, which is live real-time incident correlation. K-means is fairly well understood algorithm. What we do is take the text, convert it into vectors, because all these algorithms really require numerical values. And then the algorithm is really looking at iteratively working through the clusters. You have numerical representation of the text, and then it's iteratively minimizing the distance between the centroids. So what you see on the right side is your K-means algorithms working iteratively, and until it finds the right set of centroids, it will then stop at that point. So and there is a lot of literature in the industry. I'm just giving you one link here. What we have also done is not just the standard K-mean, but we also find optimal K. So we have some unique methods which are patent pending, where we actually provide you the optimal K. So you don't have to do these data science experiments with the AI toolbox. And that's one of the things you will see as the power of our capability. If you are a data scientist, you will have the ability to tune these parameters. If you are a citizen data scientist, then you can let the system pick the right set of parameters. And that is one of the strategic areas we are looking forward to as we bring in more such innovations. I'm going to switch gears now. The second use case, which Harshad talked about, is for major incident managers. How do we really do real-time incident clustering? Let's imagine it's Monday morning and you have a few tickets. You have two tickets here, a blue ticket, which is connection issue, backup fail issue. Yeah, they are being handled by the incident managers. All is good. But now you suddenly see one incident show up. What we do today in the background, as I mentioned before, we use a BERT model. We look for similarity of this incident with the two tickets. And in this case, we find that it's very similar to another backup fail issues. So we start forming these clusters. Uh, you don't have to do a thing. The algorithm, as every ticket comes in, it continuously compares with either the tickets or with clusters. So in this case, these three tickets came in, they got compared against everything that is in the system. And now you have these clusters forming. You have a connection issue cluster, backup fail issue, VPN failing issue. While we were talking, there were another 4 incidents. They got matched, and now you have everything was a VPN failing issues. So what you see here is a typical Monday morning scenario is you have this ticket starting to flow in, but as Harshad pointed out, there is no easy way to do this today. What we are providing you is a live dashboard where you can watch these clusters form dynamically. And in this example, you have seen that the VPN failing is a latest cluster which has formed and which will get notified based on some of the configuration parameters. So we have config parameters on how much should the cluster size be, on when to show it in the dashboard. You can set that. Yeah, I talked about similarity threshold. That's another way, another parameter which you can fine tune the algorithm. If you are looking for very sharp for clusters, then set the similarity threshold to a high value, like 0.8, 0.9. If you want a little bit looser clusters, then you can set it to a lower threshold. So again, lot of flexibility to try out things. And once you get it working, you can basically start using it. Now we go one step even beyond. These clusters are forming, but as incidents get closed, so it's like 10 o'clock in the morning, and some of these incidents get closed. So these clusters will also start closing out. So each cluster has its own life cycle, where as incidents are resolved, the clusters will actually disappear. So you will see pretty much a dynamic view of what is going on behind the scenes. So that's one thing we do. The second thing we do is really, as these clusters are forming, we are continuously looking at, hey, are there any interesting trends that are going on? So what if these 5 VPN clusters came in within an hour? Should I be concerned? That's the kind of additional parameters we have where you can set these trends. If I see 15 incidents within an hour, flag me as a possible major incident. So we provide you a number of capabilities based on trend or the slope of the rate of incidents, as well as the count. Notify me if you get like a 20 incidents in any cluster. So a lot of parameters, lot of flexibility. We do have smart defaults, but then you have the power to fine tune it as you need. So this is our second algorithm, which allows a major incident manager to figure out what's going on in my environment and detect the emerging hotspots, like in this example, the VPN failing issue. I'm going to move to the third algorithm now, which is email auto reply. Email auto reply is a pretty much fully automated AI solution. As emails are received, they go to ITSM. ITSM has a workflow engine where it looks at every email and decides, should I respond to it automatically, or should I send it to a agent? When it decides to respond, it's going to talk to this AI module where it looks at the email, figures out what are the keywords and key sentences inside the email. It gets that search string. So ITSM step 1, it will go and ask the AI module, give me the important sentences. Once it gets those important search strings, it calls the knowledge module like HKM, give me the top 3 articles. Once it has the articles, knowledge articles, it will respond back. to the user. When the user gets those articles, there will be URLs and they can click on any of them, and the knowledge articles will be presented in DWP. So essentially, it's a zero-touch handling of emails where if you have good knowledge articles, the issue that a user has will be automatically solved. So this is a very important deflection use case, and this will help support group improve its efficiency, especially if you can uh, uh, auto reply 20 to 40% of your emails. Let's dive into how it works. I'll take this example here on the left. This is an actual email about some certificate not working for my VPN. We love VPN challenges, so you'll see all my examples on VPN. So this is an example where, which is somebody writing that, hey, my VPN is not there. But what you see here is there is a lot of stuff which is not relevant, and you need to remove it, like all the salutations, signatures, HTML tags. So you have some personal information like phone numbers, names. So what we do is the AI part of this is really to remove all these surrounding noisy phrases and extract the key phrases out of this email. We have seen tremendous improvement in the results from our search engines by giving them the right text. So what it does, instead of giving this entire text, we pick the right text in the content and give it. That's what is sent to the search engines. So essentially, that's what you see as another NLP pipeline, where we receive the subject, the content in the email NLP module. We do significant pre-processing. We do PII removal. Then we use some of the algorithms like Yake and LDA to determine what are the important phrases, what are some of the IT phrases that I should be picking out of this email. And then we form this final 1 to 2 succinct search phrases, like here, which is the result of this email NLU model. So it's really trying to understand the email intent, and that's what gets sent to our knowledge engine, which will essentially be provide you a better answer than just looking at subject or looking at this entire text messages. So very powerful capability that you have in our product. Let me move to the last slide. So this is the summary slide. We talked about the 3 algorithms, and we took a deep dive. We also talked about best practices. So there is a lot of power in the product where you can both do auto machine learning, as well as you can fine tune all these algorithms so you get the best possible results. With that, I'm going to hand it back to Harshad. Harshad?
Hey, thanks, Ajoy. Um, okay, so yeah. So and before we wrap up, there are a few points that I wanted to quickly discuss, which will help you on the journey to adopting AI. Uh, so the first is, please do join our AI service management community group to keep this conversation going. And then if you're looking at detailed demos, then here's a link where you can find that. We can also post this link, on the window here. And for those customers who are on 21.3 SaaS, you must request access to this AI capability. And then finally, if you are on 20.08, talk to our BMC CSS teams and plan for an upgrade ASAP. And then lastly, don't forget to tune into the next webinar on DWP 22.1 roadmap session that will be delivered by CAF. It's going to be exciting. So with this, I'll hand it back to Samantha. Sam, over to you.
Thank you, and thanks everyone for attending today's webinar. We hope you found this useful, and we'll look forward to seeing you at the next event, which is obviously CAFS. There is actually another one before then, which is a bit more technical around DWP. Don't worry about taking links. I will be sending out shortly via a survey link to all the registrations from today's event, and in there we will include those links that we've referenced today, and also the webinar page on BMC Community. Thanks again for everyone joining.